Hey everybody. So what I would like to do in this video is talk about what an ensemble stock trading agent is and what the benefit of that is for us. So in all my previous videos, if you've been watching, we more or less train one model, and it's generally I choose the A to C model, but there's also PPO, there's also ddpg. There's all sorts of different deep learning reinforcement agents or models, however you want to call it. And one thing that we can do with FinRL is ensembleize these models into one. So we will train multiple different models on the data, and then we'll combine those models to then make decisions on our stock portfolio and see what kind of results we can get. Um, as per usual, the we want tutorials. There it is. Per usual, this is not something I came up with. As you can see, there are tons of different tutorials here that we can choose from. I'm trying to find the ensemble. Here it is. You can see that they have this ensemble notebook here that I went through, and I'm pulling a lot of the code from this tutorial here. I've put it in my own environment that I set up in the cloud in a previous video. So we'll be able to rock and roll on this a lot faster than usual. So what are the benefits of an ensemble stock trading model, and what exactly are we doing here? So in previous videos, we've only been training one model, and it's typically an A to C model. An ensemble method would be, say, training the A to C model and then training a PPO model, combining those two together, and then passing our data that we want our agent to work with through the combination of those two models. So that's what an ensemble method is, and that's what this notebook will be going through. So let's go ahead and get to it. I've already ran the notebook because training two models at once is going to be taking a while. So in this, I'm just going to be showing like what the code looks like. Of course, we're going to import our usual suspects. They help us do many things, and you just generally will need those in any notebook that you're going to be working with. The main FinRL packages that we'll be using will be getting the Dow Jones 30. We'll be using the Yahoo Y Finance. We'll be using in the preprocessor for the data a feature engineer and a data split. I find that these two features are extremely useful in helping us create a code base, or I should say a database, to pass through our agent and train on. Of course, the environment, the stock trading environment, and then we'll be using the stable baselines model. For whatever reason, I'm having trouble, and a few others have mentioned this in the comments, we're having trouble integrating elegant RL, which I think would help us because I think those models are actually more stable than stable baselines, no pun intended there. But for some reason, I'm having trouble integrating elegant RL with FinRL in my environment. I'm not sure why yet, but that's something I'm looking into. But regardless, we can still import the agents as well as the ensemble agent class as well. We're going to need to plot everything. So we're going to import backtest stats, backtest plot, get daily return, get base. These things will just help us define whether or not our ensemble method is working correctly. And then some other things that help us iterate through lists and other data points, and also create directories for our data. One thing, a few other things make the directories, and of course the config. These are the different configurations for our directories that we'll be using. that we'll be pulling on, at least in the notebook, in the tutorial notebook, that's what they use. So we've just also imported those as well. And we'll go ahead and make our directories. So to download the data, we're just going to use the Dow Jones 30. And what that is, these 30 here. So we have things like Microsoft, Nike, Home Depot, Goldman Sachs, Cisco, Disney, Verizon, Visa, a whole bunch of different 3M, right? JP Morgan Chase, Intel, Johnson & Johnson. You get the idea. Apple, Coca-Cola. A lot of very, recognizable brands, public brands, McDonald's, right? That we'll be trading on. One thing I wonder about the Dow Jones is whether or not that's actually the best index to get the kind of results that we're looking for. Typically, a lot of these stocks are not very. I don't know. I'm maybe others in the comments who are a little bit more have a better finance background than I do can maybe tell me whether or not I'd want to train on something with stocks more volatile than some of these bigger brands that I don't really expect much price movement in. But regardless, this is what we're going to be using. I just chose to train on the first 10-ish years. That's kind of what they had in the original tutorial. The dates were a little strange. Like they trained on 10 years, but then they only tested on like a week. And I don't know if that's realistic. I don't know if the alpha decay is like, am I going to have to retrain these agents every week in order to keep an edge? I don't know. So, in my sort of estimation and my testing, I went with from 1001 to 0301, right? So quite a few months just to see whether or not the alpha decay would show. And then we download it. And we just use the Yahoo downloader, which is essentially the Y Finance. If you're familiar with that package, I've used it in many of my other videos. But the Yahoo downloader is included with FinRL, and you can just pass through our configure, variables here. It'll fetch that data. It'll put it all into a data frame, and you can see the shape of the data frame is 8 by 97,000. This is the head of it. So we get the date, open, high, low, close, volume, tick, and day. Day is 0 through 5, I believe, or 0. Well, each number represents a day in the week. So day 0, my guess is either like a Monday or so. We can sort it by the date and the tick. And so you can see the earliest day in our is 0104. We have 3,311 values per ticker. And we need to pre-process this data. And we'll be using technical indicators equals true. We also want to get the turbulence. And you can use user-defined features. I haven't used them in this example, but I've just set it to false because I have no user-defined features in this instance. I know some of you have asked, how do I integrate a user-defined feature into my environment? That's something I'm learning at the moment, so just stay tuned. I'll try to make a video on what exactly this variable means and what we can actually do with it. But once we've defined our feature engineer, we can pre-process our data by passing through the data frame. We'll make a copy of it, fill in any zeros, and replace with 0 as well. So we've done that. And if we take a sample of our processed data, you can see that we have date, open, high, low, close, of course, and volume, tick, day. But we also have these technical indicators here. So MACD, Bollinger Bands, RSI 30, CCI 30, DX 30, close, SMA 30, close 60, SMA, and the turbulence. The turbulence is interesting. So the way I was reading it, the way I interpreted it, hopefully I can explain it. The turbulence is, say, quantitative quantitative marker for when the markets are super turbulent. So the agent can look at the turbulence column and see that maybe during a turbulent season, like the 2008 market crash, you would see that this turbulence spikes, right? Or dips or something along those lines. It would see that there is a turbulent market, and the agent theoretically would account for that, right? So that's what the turbulence column is meant to do. And then there's these columns here that are pretty typical technical indicators. And I just trust the folks who built FinRL that these are good indicators for predictive analysis. I've seen some comments in some videos where maybe these aren't the best predictive technical indicators. I don't know. So if if you're pretty confident in what technical indicators do well for you or how exactly we should define these, let us know in the comments. All right, so now that we've processed our data, it's time to design the environment. FinRL makes this very easy. We can just define the stock dimension as the length of the process tickers for each unique one. And the state space is twice the time of our stock dimension plus the length of our indicators times the stock dimension. And so you can see we have a stock dimension of 29, state space of 291. And then we can set our environment quargs. HMAX initial amount, buy cost percentage, sell cost percentage, state space, stock dim, tech indicator list, action space, reward scaling, print verbosity. All of these things I am learning. I'm not going to suggest that I'm an expert in knowing exactly what these mean. I can make educated guesses. Obviously, the initial amount makes sense, right? And our indicators make sense. We're talking about these indicators up here, et cetera, et cetera. And then we've just defined the state space stock dimension, right? So we know what that means. But reward scaling, I haven't played around with. Print verbosity, I can't even tell you what that might mean. HMAX, I don't know what that means either. So just be patient. If you're interested in what these are, go ahead, do your own research. I'm also learning so that I can hopefully optimize these models better for you in the future. Okay, and now that we've designed our environment, we can go ahead and design the agent. So something about Ensemble methods is you need a rebalance window and a validation window. The tutorial claims that the rebalancing window is the number of days to retrain the model. Validation window is the number of days to do validation and trading, i.e., scroll over here. If validation window is 63, then both validation and trading periods will be 63 days. Okay, so that makes sense. And then we need to initialize our ensemble agent. We'll use the DRL ensemble agent method or function, pass through our data, pass through our train periods, validation periods, the rebalance and validation windows, as well as our environment settings. And then once we do that, we can define each model quargs. So we'll be using the A2C model, using 5 end steps, coefficient of 0.005, learning rate, 0.0007, et cetera, et cetera. We do that for each one. So we'll be doing the A2C model, the PPO, ddpg, and then we'll also be creating quargs for the time steps dictionary. And we keep those all the same. Excellent. Again, these are all things that I'm learning. These are just straight taken out of the tutorial notebook here. And we'll see how that performs. And maybe when I learn more about optimization, I'll play around with these quargs with more. But this is cool, right? Because before I've only trained the A2C model, but now I'm going to be including 2 other models into our agent. And hopefully the idea is to benefit from these 2 other models. And in order to run it, we'll create a DF summary. We'll initialize. We'll call our ensemble agent .run ensemble strategy, pass through our settings that we just put for each model, and it'll go. And this takes some time. It took my GPU about 20, 30-ish so minutes, and it will just go ahead and train. And you can see it keeps going. There we go. So now that it's trained, you will see something like this at the bottom. Best model retraining from 2010 to 2022. And you can see the trading as well. It took us 27 minutes, so about 30 minutes of training. All right, so now it's time to backtest. If you've made it this far, everything from this part on out will just be getting the data that we've just, basically from this point forward, we are just trying to see the performance of our agent. So one thing that we will do is create a unique trade date, which equals the processed data frame. Within there, the date that's greater of our test start date. So we want only the dates that are greater than our test and that are less than or equal the test end date. So we just want the dates that we tested on, basically. And we're going to create a new data frame. This is just using the rebalance window and the validation window, the length of the unique trade date. We're going to make it into a CSV file. We're going to calculate the Sharpe ratio, which you can see eventually calculates out to negative 0.4737. 2223021727655. Okay, so what does that mean? The Sharpe ratio is negative, so it's not very good. Typically, what we'd want to see is something above 1. But it's okay. We're still moving in the right direction. If you've looked at my other videos, this is still a better Sharpe ratio than what we normally get. So if we take a look at our new data frame called account value.head, you can see that we have our account value, the date, the daily return, and the data date. So remember, we started out with, what did we start out with? What was our initial one? Looks like 1,000,000 buckaroos, right? So this is just tracking, if you started out with $1 million, what do you have in your account each day of the date that we are getting, right? Okay, typically you can plot this. I don't know why it didn't. If someone sees, what's wrong with my code here, please let me know, because I'm even looking at this a third time. I do not see why it's not plotting. Okay, great. So then with our handy dandy backtest stats, we can pass through this data frame and it'll give us some stats, which is very, very helpful. One thing I like about FinRL is that you do not need to go around collecting different packages that other people have written. It's all within FinRL that you can import and use. So you can see our annual return, negative 0.14, yada, yada, yada. Our Sharpe ratio we've gone over. You can see our Kalmar ratio, Omega, max drawdown. A lot of really interesting stats that we would typically use to gauge the performance of our agent. A lot of you might be thinking, wow, this is not exciting at all. But for me, I do find it exciting because before, these numbers were far worse, right? So I actually find this that we're moving in the right direction with each iteration. So I like to see that. Okay, cool. So one thing we'd like to do is just compare it. So we'll get the baseline, which will be just the Dow Jones index, and we'll compare it to the index. You can see that the baseline stats are also negative. So we're not doing too bad. If the Sharpe ratio Just the Dow Jones base index is negative 0.4, then perhaps we are also not doing too bad, right? Or we're not that far off from just the index itself. So what is this? So this is basically I was making CSVs of the index and adding it all into one data frame here. You can see it printed out a bunch of stuff. This was also included in the tutorial notebook, but it just, I think, helps save the data that we just built on. So this is what that looks like. But this is combining the Dow Jones with our account value that the agent passed through, and we can finally plot it because visualizing it is the best way to understand it. And this is, let's see, this one. The tutorial wanted to do a lot of stuff. I feel like this could be cleaned up a lot, but the real reason I just copy and pasted it into this cell was because I wanted, pay no mind to that graph, I wanted this graph. So orange is our baseline index, blue is our ensemble agent. So you can see that throughout most of the year, the ensemble agent was performing better than the index, just slightly. And it wasn't until 2022-ish, somewhere in here, that the later part of 2022, it looks like, that it started to fall behind. So very interesting. The performance is, I think, comparable to the index. This is a portfolio that I don't think is doing too bad. Obviously, we would want this to get better, and I think we will, with just a little bit more tinkering, some more optimizing, and whatnot. So hopefully you guys found this interesting. Like I said, if you haven't and you're interested in reinforcement learning, go ahead and check out FinRL tutorials. There's like a million, there's not a million, but there's a ton. There's a ton to learn from introductory notebooks to more advanced and practical, all the way up to optimization, where you're hypertuning, hyperparameter tuning, right? These are the ones that I'm currently trying to learn and try to understand. So yeah, right now I'm working on a multi-crypto trading agent that a lot of these tutorials in here are outdated and do not work anymore. So I'm trying to fix those notebooks, and I just wanted to get something out this week. I hope you guys like it, and I'll see you in future videos. Be sure to leave a comment. It's probably the best way for me to understand what you guys are looking for and what you want me to research. So it also helps me kind of point me in the right direction of where my weaknesses are and what could really benefit me. So yeah, that's it for today. I will see you in the next video. Take care. Bye.